So now we will see the different types of fuel cells. So based on the electrolyte type, we can have different types. So the first one is proton exchange membrane or solid polymer fuel cells. And second one is phosphoric acid fuel cell. Third one is alkaline fuel cells. And we have molten carbonate fuel cell, solid oxide fuel cell, and even direct methanol fuel cell, and also reversible fuel cells. So you can see the different ranges of power production, they are available with different types of fuel cells. So here PEMFC, that is proton exchange membrane, is there, which can give you the power in the range of 1 to 100 watts only, whereas alkaline fuel cell can give powers from 1 kilowatt to 10 kilowatt, and the maximum power output can be possible with MCFC, that is molten carbonate fuel cell, right? And there are different advantages given here. So the main advantages of PEMFCs are higher energy densities than batteries and faster recharging. So but the power density is less, that you can see from here, it is up to only 100 watts, right? And the advantage of AFCs, SOFCs are that they are having more potential for zero emissions and also higher efficiency. And coming to the MCFCs as well as PAFCs, the efficiency is very high and gives rise to less pollution. Also they are very quiet. Okay, these are the comparison of different types of fuel cells with respect to power and advantages, as well as applications are given here. So for vehicles, portable and electronics equipment, you can use fuel cells, like, and for cars, boats and domestic CHPs, like that is combined heat power production, we can use AFCs as well as SOFCs. Coming to the PAFC and MCFC, we can use them for distributed power generation as well as combined heat powers, as well as for buses, because they required more power, we need to go for the more power output fuel cells, right? So we even have low and high temperature fuel cells. So based on the operating temperature, they are separated. So low temperature or first generation types are the one which include AFCs and SPFCs or PEMFCs, they are same, and also phosphoric acid type. So these comes into low temperature fuel cells. And we have second generation or high temperature fuel cells such as MCFCs and SOFCs. So all these abbreviations are generally used, you need to remember these, which are considered as second generation, and their commercial development is at an advanced stage, being considered for use in large scale electric power generation, because they are of high temperature type and they represent an important advancement in fuel cell technology, offering improved efficiency, fuel flexibility and tolerance to impurities. It is very important to have tolerance to impurities such as carbon monoxide and all, because they will reduce the performance of fuel cells. So that is very important, which is there for high temperature fuel cells, right? Let us see some more description about these fuel cells of different types. So PAFC, so what is PAFC? PAFC is nothing but phosphoric acid fuel cell, right? So it is using phosphoric acid as the electrolyte, whereas MCFC uses high temperature compounds of salt like sodium or magnesium carbonates as the electrolyte. So the electrolyte is different in each fuel cell. What about alkaline fuel cell? It operates on compressed hydrogen and oxygen. They generally use a solution of potassium hydroxide, which is potassium hydroxide, that is KOH chemical formula, right? And what about SOFC? This is the one which uses a hard ceramic compound of metal oxides like calcium oxide, zirconium oxide as electrolyte. Okay. And what about PEM? What is PEM? PEM is so PEMFCs are nothing but proton exchange membrane type. So they use a polymer electrolyte in the form of a thin permeable sheet. Okay, so PEMs work with polymer electrolyte in the form of a thin and permeable sheet. This is about the different electrolytes used in different types of fuel cells. Okay, here you can see the PEM is PEM is not proton exchange membrane one. There are two names for PEMs, like proton exchange membrane is there. We can see we can also have proton. Okay, that is the one. Okay, the same one. Then there are no two different things. It is same. That is proton exchange membrane, which is also same as that of solid polymer fuel cell. Right, it's fine. So here you can see the different electrolyte traveling ions and cathode and anode. So if you see proton exchange membrane FC, that is PEMFC, uses hydrogen as input at anode and oxygen as input at cathode, and the one which is traveling from anode to cathode is hydrogen within the electrolyte and electrons outside, right, outside the electrons will be going towards the load, so that load can use the electrons motion, that is current, right. Of course we will be getting H2O as a byproduct, and the operating temperature of this fuel cell is 80 degrees centigrade. So the same thing can be applicable for all other fuel cells. You can see here. So even direct methanol fuel cell is operating at 80 degrees centigrade, and it is taking methane hydroxide as input at anode, not hydrogen, and it is giving out CO2 as well as H2O, and oxygen is also common at cathode. And you see oxygen is common for all the fuel cells, right. Okay, then alkaline fuel cell we have, where hydroxide ions will be traveling from anode to cathode or present in the electrolyte. Fine. If you look at the phosphoric acid type, hydrogen is input, oxygen is input at cathode, hydrogen is input at anode, and H plus ions will be traveling in between through the electrolyte, and H2O is the output. This PAFC and PEMFC chemical reactions are almost same, right, but this operates at 200 degrees centigrade, this operates at 80 degrees centigrade, right. Coming to the molten carbonate, the hydrogen is in, H2O is out at anode, CO2 is also out at anode, whereas at cathode oxygen as well as carbon dioxide are inputs. And carbonate ions are the one which are traveling within the electrolyte, and electrons will be coming out from anode to cathode through the load. That is how electricity is produced in case of fuel cell. And in case of solid oxide, you can see oxygen is the one which is moving from cathode to anode, right, and oxygen is the input at cathode, and hydrogen is input at anode, H2O is coming at anode, right. So the electrolytes in different fuel cells are also discussed just now. So this is how you can explain all the different types of fuel cells, right. Then we will discuss in detail the each fuel cell type and their chemical reactions and all. Thank you.